you're awesome. You came here, you made this video awesome already. Hi, I'm Ritesh Agnihotri and today we're going to talk about Big O notation. So before going into Big O notation, I want you to imagine doing any daily thing that you do in your daily life basis. If it is driving a car, playing football, anything. Whatever you do, you want yourself to do it in an efficient way. Same goes with the program. Program has to be efficient enough. So, Big O notation is that measure to measure the efficiency of an algorithm. As you can see, Big O notation stands for simplified analysis of an algorithm's efficiency. So, there are three characteristics of Big O notation. First, the complexity of an algorithm is expressed in terms of n, input. Second is machine independent. It doesn't matter in which machine you are writing a code, it is same on every basis. Third is time and space. So the efficiency of the algorithm has to be efficient enough in terms of both time and space. So how to measure the efficiency? There are three cases majorly used: worst case, best case and average case. Basically, developers use these two cases. If an algorithm is best, it is accepted by the developer. If it is waste or worse, it is rejected by the developer. Now let's talk about some general rules. There are two rules. First, the constants are ignored. So here, as we know, the input is measured as n. So n, 5 of n, 5 will be ignored, and we will say that the efficiency of Big O notation of this algorithm is, this statement is O to the power O to n. Second is certain terms dominate others. Now there are some basic computer steps, on which their efficiency depends. The first one is constant time. Observe this statement. This statement is independent of n, as the rule suggests that the input efficiency is determined by the factor of n. There is no n, so it is independent of input n. So in this case, we say that the Big O notation of this statement is O of 1, Big O of 1. Now imagine that now you have two statements. Both are independent of n. Now what is the complexity? So we will add it. O of 1 of this statement plus O of 1 of this statement. It gives us O to O of 1. We know that constants are ignored, so it would be O of 1. Second one is linear time. Observe this statement. For x in range O, n, the statement is printing numbers from 0 to n, right? So, and it is printing x. So, Big O notation of this is, we know that 1, and it is being executed n times. So, it is n into O of 1. Basically, it is O of n. Linear time. It is the most efficient one. Now, here comes quadratic time. It's the most inefficient one. How? I will tell you. Let's have a look at this code. Right? X equals to this. This is independent of n. This is printing numbers from 0 to n. And this is initializing. There are two nested for loops. Right? And here is the result of that. So, in the first case, we know that independent of n. O of 1. This is O of 1, this is O of n, as this is being executed n times. There is two for loops, and here is the result printing. So it is O of n square. So this n square will dominate over these two, and hence will result in the Big O notation of O of n square. Now, these were three basic statements. There are many more, but these are three general. So I wanted you to be precise. So whenever you code, make sure that they are efficient enough in terms of time, space, both, and practice more, as it will build your analytical mind and best of luck for the coding. Thank you. Thanks a lot for watching this video.